All right, good morning. So today I was actually wanting to do a bit of a recap on AI agents still, um, and just sort of go over what they actually are, what they do, how they're built, and where it started and where it's going, more or less, right? Just a quick sort of like general overview of the whole thing still. So um, when we're talking about agents, we're going to stick with the concept that these things are broken into two different categories, right? There are agents that you would interact with, you personally, and then there's fully autonomous agents. Okay, so I guess the way that I like to see it still is that the simplest agent that you can build is basically, like a chatbot that more or less has like something besides just talking and like generating text from its model, right? So it just has to be sort of like one step above that, right? In order for it to kind of be an agent still. Now that is not necessarily a fully agreed upon definition of what an AI agent is, but for the purposes of this sort of discussion, I think let's start with there. So what is sort of the simplest agent you could build? That would be a large language model that has a reinforcement learning, fine tuning to get it to operate in a conversational format, right? So this is the one that ChatGPT is, and I think it's the one that everybody should be pretty familiar with this by now, more or less, right? The idea that you type in some stuff as if you're chatting to another person, and it's gonna give you a response, right? Now, there's the next step after that still would be to give it some sort of additional abilities besides only the only access to that large language model, right? And we're gonna sort of gloss over the different types of fine tuning and sort of the different ways that a large language model can be constructed to give different sort of different results just by itself. So we're just gonna kind of skip that over and go right into the additional functionality, right? So let's say you have a two-step process now where you would enter in some text into the chat window, right? And then before that goes to a large language model, that could go into a different kind of tool or a different kind of process. It doesn't even have to be like tool calling or anything at this point, right? It could just take that raw text and then send it to, let's say, some function that scans for specific keywords, right? And then would modify the text that would get sent to the large language model based on those specific keywords, right? So let's say if it is looking for like the names of people, right? And maybe that function could look in your contacts list or something, right? And it could pull back the contact information for that person, right? Now then you could do a second step where it sends it to the LLM, and then it would format that in a conversational style. Maybe if you have more than one result, it's like, hey, what's Bob's phone number, right? Maybe you have 3 Bobs in your contact list. And maybe in the course of that conversation, it was clear which Bob you're talking about, and the AI could figure that out for you and select the correct Bob. The really simple example here. So the point being though is that it's just there are multiple steps that are happening, and you as the user wouldn't necessarily see that, but behind the scenes, that's how it goes. Now, we can get way more complex, obviously, still. But let's try and take it step by step here. So one of the other very common tools that AI agents are using now is called a vector database, right? And so that goes through a process kind of like this, where You will type in something. Let's say you have a question, right? You're just like, what happened, in 1066, right? Now, probably the model will already know that because it's ingested a bunch of data, right? But let's say that you have a bunch of history books in your vector database, right? And just a quick aside, what a vector database is basically it's a bunch of information that has been analyzed by something called an embeddings model. The embeddings model will create numerical embeddings that are a reference point to pieces of text that is stored in the database, right? So your input would then go into the database, your input would then go into the embeddings model, create an embedding from your input, and then the numerical values of the embedding that you created from your input would get matched up to anything in the vector database that is fairly close, right? And obviously there are configuration settings to say like sort of how close those matches need to be. Then it would return the chunks of text from that vector database, at which point you can include that the returned text as part of your context window that goes into the large language model. So the context window is just the full amount of text that is being sent as an input. Okay, it's not super complicated here. And then at which point the large language model would format its response and send it back. So it would be including that sort of, it's static information in those databases, right? In the sense that, it's unchanging and it's not being generated, it already exists, right? So for example, like you could take, if you're so inclined, you could take a Wikipedia, for example, right? And you could create a vector database of Wikipedia. And you would go through all of the text and all of the pages. You would break it into chunks or, some other sort of formatting, create embeddings for all of those chunks. And then that would be your database. And then every time that you have matches that are near enough, it would pick the top ones and then inject that into the context window, send that to large language model, formulate a response. Okay. So next we have something called function calling or tool calling. And this is where, as part of the instructions to the agent, so this is starting to get a little bit more complicated here. So what we've kind of done here is we have in these conversational agents, there's something called a system prompt. The system prompt is basically the general instructions for the agent, telling it, what are its directives, what's its purpose, and in this case, we're telling it what tools does it have available, right? What functions can it call upon, right? So in this case, it is going to do one step to analyze the user input, right? So what it's going to look at the text that the user has typed in, try to match up sort of the intent of the user, or what it would need to fulfill the user's request. Look at the list of tools and functions that it has available to it, and then it would format something called an API request. And API stands for Application Programming Interface, and basically that is just a way that software can talk to each other, right? It makes it accessible to things that are outside of the software, right? So this means that you could access all manner of different software in the cloud. You could have APIs running locally, all kinds of good stuff. And they can do, it's not really any hard limits on that. It's just as long as it's data in and data out, like you have a request and a response from those API endpoints. So what happens there is that the large language model will then, after it sort of understands that, okay, these are the tools, this is the user intent, I'm going to pick the tool, and then I have to format the request body, and that is formatting the message that it's going to send to that API, that other piece of software, to give it instructions on what it wants to get back, what needs to be returned in the response. Now that needs to be structured typically in a specific format. Very often this is done in something called JSON, which is called JavaScript Object Notation. And it's just a way to structure information, more or less, right? So that structured information would get generated by the large language model after doing that previous analysis, send that request to the API, so it would call the software, it would get an answer back, get the response back, and then that response would again get injected into the context window. In other words, the answer, the text or the information from that answer will get put into the next step where it talks to the large language model, and then that takes in, again, all of that information and will synthesize the response and send that back to the user. Right? Now, at this point, with those two sort of abilities there, the ability to do semantic search in a vector database, or this is, where we talk about the embeddings, and then also the ability to do, function calling to APIs, you can have an agent that is very capable, right? Now, there are other ways to make the large language model smarter in the context of sort of building an agent. And this is something called prompt chaining, right? And now we've already kind of been doing that because there are multiple steps that we just talked about. But prompt chaining can actually be done independently of calling any external tools like a vector database or even a regular database or any other kind of API. That can just be done by calling the large language model over and over again, and basically like going through a process that will ultimately generate a superior response than a single call to the LLM would. So I'll give you an example here that should be easy to understand. So let's say you want to write a blog post, right? You could just tell the agent that you want to write a blog post about cats or something, right? And then you could let it do a single response and you'd probably get something okay, right? Now, if instead we structured it so that it would have one call to the large language model that asks it to create an outline for that blog post. And then for each step in the outline, it would make an individual call to that large language model to write the section of the blog post based on the outline. And then you can take it into further steps by asking it to review the content that it wrote, look for ways to improve it, execute on those improvements, do a final proofread, and then send that final version back into the process flow, right? So this is without using any other external tools, just with a large language model, you can get much, much better results, end up with larger, longer formatted documents, that can all be done, in a sort of like a long format process. And the user doesn't have to see any of this still, right? They can just type in their request. Now, obviously this will take longer, right? Because instead of a single call to the large language model, it is doing multiple calls, it can be taking the outputs and then sending it in as a new input or part of a new input over and over and over again, right? And you would actually not see any of the process that's happening, unless you design it in a way that you want to see it, and then you would just see the output, right? Now, I want to go back to the sort of advancements in the reinforcement learning layer of the large language models, because we have one that has become very popular nowadays called reasoning or chain of thought. And basically this is where you can actually see it work in these steps, right? Where it will take your input, it will think in steps on how to complete it, and then provide the output, right? And these are done in a single call, right? And this works because the training data that is used for the models is formatted in a way to show these thinking steps and then the response, right? And so this actually kind of replicates what previously would have been done in a prompt chain, right? Where maybe you would have had to make two calls. You would have to make one call for it to do the thinking steps and then a second call to execute on them. because again, the models will provide responses based on the training that the model has been given, right? So the format of the training data really determines what the output of these models will be, right? So in this case, there was a significant amount of training data being used on these models that is explicitly in that format, right? In that reasoning chain of thought format, right? So now next, we want to move even further into fully autonomous agents. So this would be where an agent is given an overall directive or maybe specific directives, but there's not any human intervention. It's not a back and forth at this point, right? So how would you make the agent be fully autonomous, right? Well, for starters, it needs to have something to trigger actions, right? So this could be setting a timer using something like crontab or cronjob, where basically it would say, okay, every 5 minutes, check the price of Bitcoin. And then if the price of Bitcoin is like up 5% or down 5%, then run, task A or task B, right? And then those tasks could, involve large language models, and then, some of these other sort of tool calling and stuff like that. You could also have it be event-based, right? Whereas instead of running on a schedule, it's just always listening for some sort of external input, right? So maybe you have it listening for messages, incoming messages, like on a chat app or something, right? Like, so if somebody sends you a message on WhatsApp, and then you would feed that message into a process, it would respond and then send it back, right? And you're not doing anything. It's just the system is behaving automatically in that sense, right? And now that, it doesn't have to be a chat message. It could be any piece of data input that runs through sort of, some business logic to determine sort of what to do next, right? And I mean, like, it could go much, much further still. There are ones where it goes in recursive loops. So this would be, it will have a large sort of set of directives that explains the different abilities that it has, and then once it's given an overall objective to execute on, it will continue going in a loop, calling the different functions, getting in the responses, understanding where it is in the process, what its status is, and then eventually, once it reaches a point of completion, the loop will stop, right? And that's sort of more or less where we're at now still. Now, obviously, we could get into things like multimodal, where it's doing image segmentation and using computer vision as part of its input. We could have it, working with different types of outputs like, speech, video, and images. But I think that's probably good enough for now for the purposes of this. So I hope that this sort of made sense, at least a little bit. And we'll see you all in the next one.